Broad physical categories are the most fundamental, most abstract concepts scientists use when understanding the physical world. Examples of these categories include entity, property, action, and cause. This presentation will put forward a unique way of thinking about these categories and will demonstrate how each of them can be used as powerful tools of scientific reasoning. Motivation. Scientific knowledge has given mankind sight beyond sight. Having never gone to space, Aristotle could see that the Earth is a sphere. Having never seen an atom or a molecule, the chemists of the late 1800s knew the shape of molecules. Using spectroscopy, astronomers know the chemical composition of stars which are light years away. Science must only use data from the five senses, but somehow science allows us to understand things which are far beyond the reach of the senses. Aristotle could see that the eclipse shadow was a circle, but it required inference to figure out that the Earth was a sphere. He had to reason from the fact that the Earth cast a circular shadow upon the moon, regardless of the angle it cast that shadow. In general, by understanding the things that we see, concepts allow us to deduce our way to facts that we cannot see. Aristotle was able to reason from the nature of light, from the nature of a sphere, from the nature of the fact that it will block light in a certain way. And he was able to reason from these facts to deduce that the Earth had to be a sphere. And that leads us to my major new insight. Inference allows us to discover fundamentally new things which lie beyond the reach of the senses, such as electric charge, atoms, and gravitational fields. Discovering fundamentally new classes of things, however, requires a special kind of inference, a special kind of deduction. Aristotle had seen a lot of spheres in his life. All he did was infer the existence of a sphere which was too large to directly observe. Discovering something like a gravitational field, something which is not only hidden from view, but is some new type of thing which has never been seen or even dreamt of, that kind of discovery requires a special kind of inference. This is the kind of inference that a species of blind aliens would have to make in order to discover the existence of light. And this kind of inference, as we will see, is made possible by reasoning with broad concepts such as entity, property, and action. Now, let me demonstrate how these categories help us infer the existence of new things. In Lecture 12 of the Inductive Summary of Physics, William Gilbert observed a glass rod pick up little pieces of paper. Now, from this observation, Gilbert knew that his glass rod had a property that most objects don't. He called this property electricity. Now, he can't see this electric property in the way he can see properties like red or long, but he knows that it's there. Now, he can't see the rod's electric properties, but he can see the rod's actions. He can see that it picks up paper. Now, if Gilbert knows that entities always act in accordance with their properties, he can infer that this glass rod has a property that other objects don't, since he can see that it acts in a way that other objects don't. He sees a new action, therefore he knows by inference that there is a new property. Just as an understanding of how light interacts with spheres allowed Aristotle to deduce that the Earth is a sphere, understanding how actions imply properties allowed Gilbert to deduce the existence of a brand new property, in this case, electricity. So here is the value of broad physical categories. By labeling the broadest kinds of existence and identifying generalizations about them, we are able to infer the existence of new kinds of existence, which lie beyond the reach of our senses. Once your knowledge has progressed beyond the reach of the senses, by the way, broad physical categories allow you to go even further. Reasoning from an understanding of things you have inferred, so for example atoms, to things that are even further removed from sense data. So for example, the electrons, protons, and neutrons that atoms are made out of. Now, formally laying out these broad categories will yield two immediate benefits. First, it will give us powerful tools for scientific inference. Throughout this presentation, I'm going to be showing you how each of these categories could have been used by the great scientists of history to direct their investigations and prove their conclusions. Second, formalizing these categories will give us a chance to redefine them when needed. When I first started thinking about these categories, I realized that many of them needed to be reconceptualized. So my definitions of these categories will allow the inducers of the future to make inferences even more effectively than they have in the past. And throughout this presentation, I will be explaining precisely how my definitions capture key distinctions and similarities that the standard definitions of these words do not. So, the values I have laid out motivate the following question. What is the proper way to conceptualize the broadest categories of physical existence? Categories such as entity, property, and action. Now, my answer to this question is given in a 2-page document, which you can find a link to at the bottom of the video description. This document gives my definitions of each of the broad physical categories. During this presentation, I will explain why I conceptualize each concept the way that I do, and I will show how my particular conceptualization facilitates scientific inference. I encourage you to follow along with that document during this presentation and always refer back to it to remind yourself of earlier definitions as we proceed, since each definition actually builds upon the last. Okay, now, these definitions were painstakingly arrived at. I worked for months using the method of cross-conceptualization, which is an epistemological method that you can see demonstrated in one of my previous videos, and I've linked to that in Citation 5. The citations can be seen in the description. Note also that these concepts in the document go in an order of a conditional hierarchy. This is the order of OPAR or Euclid's elements. So for more on what a conditional hierarchy is, or as I used to call it, a causal hierarchy, for more on that, you can watch one of my previous videos, which is found under Citation 6. Okay, let's get started. The first two concepts are physical existent and identity. Okay, now, physical existent and identity, these two words cannot be defined. They can only be gestured to. So look at my hand. It's a physical existent. And to exist is to have identity. In other words, my hand is a certain way. It has identity. Because physical existent and identity are the broadest categories, you actually can't define them because they don't belong to a wider category. So these are the basis of everything else. Everything else is a physical existent with identity. Okay. The next two words on the list are entity and property. So let's define these. Entity, an existent having particular properties. And property, an aspect of an entity's identity. Okay, now, notice that these two categories mutually condition one another. Each term appears in the definition of the other. So I put them side by side in the list at the same level of the hierarchy. Now, this is controversial. The standard way to think about entity and property is that because all properties are properties of entities, that entities should come first. So that sounds pretty straightforward. And that's true. All properties are properties of entities. So entity does condition property. But what we validly designate as an entity is something which has particular properties. So property actually conditions entity. So let me explain what I mean. Let's think about a door. A door is an entity. It has properties which belong to the door as a whole. The object moves as a rigid body. It's made of hinges, a plank, and a knob. All of these parts maintain the same shape as the door rotates. This is to say that the door as a whole has certain properties. However, the knob, which is just part of the door, is also an entity in its own right, since it also has a certain shape and rotates as a whole. You can see different things as entities depending on your perspective. You can see the entire house as an entity, and the door is just part of it. You can see the earth as an entity, going around the sun, and the house is only part of that. So can you just draw the lines anywhere you want and call anything an entity? No. What makes something an entity is that it has properties. And whatever parts are required to have those properties is part of the entity. For example, when you're talking about the door, you can't exclude the knob, since it moves along with the rest of the door and is part of the door's shape. On the other hand, you cannot designate the left side of the door and, like a layer of air 1 millimeter above the door as an entity, because that set of stuff has no particular property which is possessed by the whole. So what you view as an entity is a matter of perspective, but that perspective must be based on the thing which actually has properties. And what we find in the history of science is that it's helpful to be creative about what you consider to be an entity. In lecture 6 of the inductive summary of physics, Archimedes identifies a very special entity, which is a piece of water which would have been there if a boat wasn't. Okay? Now he's treating this piece of water as a separate entity, and it is. It's an entity which ends up being pushed up by the waters below it with the same force which would have pushed up on the boat if the boat was there instead. Since this body of water has a particular property, again, that property is kind of complex, but it is a particular property. That property is it's being pushed up by the same waters which would have pushed up on the boat. Because it has a particular property, it is valid for Archimedes to identify it as an entity. This perspective allowed Archimedes to think about the force that the surrounding waters exerted on a boat, which caused it to float. Incidentally, if you're unfamiliar with any of these examples I'm going to give from physics and you want more information, you can find a link in the description to different segments of the inductive summary of physics where I explain each of these examples. So let's turn now to the word characteristics. Characteristic, an aspect of an existence identity. Now, characteristics are not to be confused with properties. Properties are aspects of entities, while characteristics are aspects of any existent. So, for example, hard, that's a property of an entity. Fast, that's a characteristic of an action. Far, that's a characteristic of a relationship. Okay. Properties in this conceptualization belong to entities, and characteristic, the word characteristic, is a broader class which belongs to any existent. So that's an important distinction. In lecture 10 of the inductive summary of physics, when the underlying nature of sound is not understood, scientists refer to pitch as a characteristic, since they don't know whether it's a property or not. They don't know if the pitch is a characteristic of a particular entity. Now, it turns out that sound ends up being an action, and pitch ends up being the frequency of that action, so pitch ends up being a characteristic. But having a clear distinction between characteristic and property allows us to clearly identify when we're talking about a property of an entity and when we're just not sure. So when we're not sure, we use the word characteristic. And that leads us to the next term, which is conditioning connections. Conditioning connection, a characteristic of an existent where all or part of the identity of that existent is dependent in part on a characteristic of another existent. So let me give an example of this. The strength of a beam is conditioned by the kind of material it's made out of, whether, say, wood or steel. Now, conditioning connections are often referred to as causal connections. But that standard conceptualization of causal connection packages together two things that actually aren't the same. Causal connections involve time. First there's a cause, then there's an effect. Because of this, cause should only refer to specific conditioning connections which involve action. But not all conditioning connections, not all connections between facts actually involve action. In the case of the Pythagorean theorem, one property of a triangle, it's having a right angle, necessitates another property of that triangle, its sides obeying certain ratios. This relationship, this formula, is not the result of some action, but a result of a relationship between the sides. It's not like first there's a right angle and then only later the ratio between the sides happens. That's not how it works. So we need a category, conditioning connections, to refer broadly to all connections between facts, while reserving the category of causal connections to identify conditioning connections which involve action. So since my conceptualization captures differences that the standard concept of causal connection does not, it should replace the standard concept in your vocabulary. This is what it means for concepts to be objective. Is that some conceptualizations are better than others. Now, conditioning connections are the payoff of all knowledge. By understanding how certain characteristics depend on others, we are able to predict and control nature. This is the reason knowledge is power. If we need heat at night, we ignite wood. Why? Because we know that burning causes heat. If we need a building to have more strength, we build it out of steel instead of wood, since we know that material conditions strength. If we want to light our homes, then we run electric current through wires, since we know that electric current causes a wire to glow. So conditioning connections are the most powerful weapons in mankind's arsenal in his quest to conquer nature. And that leads us to a variation on conditional connections, which is necessary connections. Necessary connection, a characteristic of an existent where all or part of the identity of that existent is entirely determined by a characteristic or characteristics of certain other existence. Now, what this refers to is the full set of conditioning connections which determine the identity of a given characteristic. So here's an example of what I'm talking about. The position, velocity, and net force of a physical object, of a body, necessitate the location of that body at later times. These factors constitute the full set of conditioning connections which determine the body's future position. Another example. In lecture 6 of the inductive summary of physics, scientists found that pressure, temperature, volume, and mass of a gas all mutually necessitated one another. This is the classic formula, PV equals nRT, only I have it in a different form during that part of the induction. So, in other words, for a specific volume, mass, and temperature, the gas must exert a certain pressure on its surroundings. Now, before this general law was known, however, Robert Boyle found just the connection between pressure and volume. Now, Boyle was able to see the connection. He was able to see that squeezing a gas, reducing its volume, increased the pressure it exerted on its surroundings. But he found that the amount of pressure it exerted was not the same for any given volume. It actually varied from day to day. So he therefore knew that there was additional factors which conditioned the volume of the gas. He couldn't see what those additional conditions were, but he could infer them. And he could have made that inference rigorous using these broad physical categories. And understanding that there were additional conditions motivated future scientists to search for those additional conditioning factors. So the concept of a conditioning connection versus a necessary connection allows us to conceptualize when a set of characteristics constitutes all or only some of the factors which necessitate some other characteristic. And this allows us to identify situations where there are unknown conditions, which then prompts us to seek them out. Our next word is relationship. Relationship, a property of an entity where a property or set of properties of that entity are conditioned by the properties of another entity. So note here that relationships themselves are a property. They are an aspect of an entity's identity. You can look higher on the page. You can see properties are aspects of an entity's identity, and a relationship is a property of an entity. It's an aspect of an entity's identity. That's the way I'm conceptualizing it. You'll see why. Specifically, relationships are a property which conditions an entity's other properties. So, for example, a stick has a certain strength. That's a property. But when it's woven in with a bunch of other sticks into a fence, when it's in a particular relationship, its strength is much greater since each stick is braced against each other stick. And that bracing is the relationship. Changes the properties of each individual entity. Now, you might be thinking that it's more appropriate to call this an action. Now, action and action is involved, since if one stick gets bent, it's going to press against the other sticks and bend them. But to identify a relationship is simply to identify the way that each stick changes the properties, in this case, the strength of each other stick. We need a concept for how one entity can influence the identity of other entities in ways which aren't action. The reason we need that, a separate concept, is because action involves change. And entities can influence each other's properties in static, unchanging ways. So these sticks are not acting on one another, they are in a relationship with one another, conditioning the properties of one another. Now, in lecture 2 of the inductive summary of physics, Kepler found a mathematical equation which related the distance of a planet to the sun and the time it took for that planet to go around the sun. In this case, here's what Kepler can see. A property of the sun, namely its distance away from a planet, conditioned a property of that planet. So since a property of the sun conditioned a property of each planet, Kepler could use this concept of relationship that I've put forward to know with certainty that the sun was in some kind of relationship with each of the planets, even though that relationship could not be observed, not even with a telescope. Note that Kepler did this before gravity was discovered, and indeed, finding out that there was some kind of relationship between the sun and planets is a crucial step towards discovering gravity to begin with. Now, let me give you a quick differentiation. Relationships are not the same thing as conditioning connections. Relationships are the way that the properties of some entities condition the properties of other entities. On the other hand, conditioning connections refer to any two facts conditioning one another. So, for example, the speed of a ball is conditioned by the speed of a bat that struck it. So what I'm saying is a characteristic of action, the speed of the bat, conditions the characteristic of another action, the speed of the ball. We want a word for how two characteristics can be connected without talking about the specific ways that the entities involved condition one another, without necessarily talking about the specific nature of the relationship. Even though we want to talk about the connection before we understand the relationship which gives rise to it, we still have to remember that there is a relationship. If Kepler had just noted a correlation between the distance and the orbital period and then just stopped there without thinking of the relationship which was behind that correlation, then science just wouldn't have progressed. And that is essentially the position physics is in right now historically. Let's move on to two terms which come about as a result of relationships. First, constituent entity. An entity being in a relationship or set of relationships with another entity or set of entities, constituting a composite entity. And second, composite entity. An entity having particular properties conditioned by a set of constituent entities and the relationships between them. Now, an example of a composite entity is a wicker fence made of many interwoven sticks. Each stick has its own properties. It has a size, strength, color, etc. But when we bring these sticks together, the fence as a whole has properties that the individual sticks do not. The fence can now impede the progress of animals, while individual sticks cannot. As I've said before, once a whole has properties of its own, then that whole is a single entity. Now, further, the way composite entities come into relationships with external entities is not based on the properties of the parts, but based on the properties of the fence as a whole. This is what it means for it to be a whole. And this fact has two aspects. First, when a composite entity is in a relationship with an exterior entity, the properties of the composite entity as a whole are altered by the relationship. So when an animal presses against the fence, it bends the whole fence. It bends all the sticks, not just one of them, because the sticks are interwoven. Okay? The other aspect of this is that when a composite entity is in a relationship with an exterior entity, the properties of the composite entity, not its constituents separately, but the properties of the composite entity as a whole condition the properties of exterior entities. So when an animal presses against the fence, the animal experiences a force which is dependent on the strength of the fence as a whole, not the strength of the individual parts. Now, this perspective is, of course, indispensable in the formation of the atomic theory of matter. In Lecture 7 of the Inductive Summary of Physics, we learned that when hydrogen and oxygen gas are exploded together, they form water. So just like the fence, water has properties that the constituents do not. It's a liquid at room temperature, while hydrogen and oxygen are gases. Just like the fence, it comes into relationships with exterior entities as a whole, not as its constituent parts. So for example, when a person drinks it, it will quench his thirst. It will act on the human body in the way water does, not in the way hydrogen or oxygen do on their own. Chemists could not see the relationship between hydrogen and oxygen after the explosion, but they could see that when hydrogen and oxygen come together, they form a completely new entity with completely new characteristics. And as a result, they could infer the existence of an invisible relationship between hydrogen and oxygen. Since physicists knew that there was such a relationship, they were able to identify that relationship later as covalent bonding. the sharing of electrons. Now let's turn to two terms which will help us think about composite entities and their constituents. And these terms are matter and form. Matter, the constituent entities which make up a composite entity. Form, the set of relationships between the constituent entities of a composite entity. Matter matters because the kind of constituents a composite entity is made out of conditions the nature of the composite entity. So for example, the bricks as part of a castle. Heavy bricks, different matter, might make the castle stronger if the enemy uses explosives against it. The stuff that the castle is made of conditions its properties, in this case, the strength of the castle. In Lecture 7 of the Inductive Physics Project, we can see that combinations of different substances, different matters, create different compounds. Oxygen and metal make rust. Oxygen and hydrogen make water. Different elements in combination will create different compounds. If we want pure oxygen, perhaps for medical purposes, then we can melt rusty metal. If we want to prevent a metal from rusting, we have to prevent that by somehow preventing the metal from binding with oxygen. So the concept of matter, the practice of identifying the parts that something is made out of, is a key aspect of understanding why things are the way that they are. Now, form is also important because the relationships between constituents condition the nature of a composite entity. Let's return to the wicker fence example. The particular way the sticks are interwoven will condition the properties of the fence. If they're clenched tight against one another, the fence will be strong. If they're only loosely woven, then the fence will be weak. Now, as an example of form, from the Inductive Summary of Physics, Lecture 16, the concept of form actually helped chemists identify the property of isomers. Isomers are different compounds which are somehow different despite being made of the same elements in the same mass ratios. So since their matter is the same, it was hypothesized that their form, the relationships between the constituents, are somehow different. Specifically, different isomers of a compound are said to have different spatial arrangements of their constituent atoms. Now, these two categories are, you may have noticed, they're not mine, they belong to Aristotle. But what we'll find through this presentation is that I've often taken the concepts of other philosophers who have come before me and altered them to integrate them with the rest of my framework. And that brings me to another set of ideas which come from Aristotle, which I've reconceptualized. I will call them the four conditioning connections, and these are based on Aristotle's four causes. First is material conditioning, a conditioning connection between the matter of an entity and its properties. For example, the strength of a fence is conditioned by the material of its parts. If they're iron, so like in a house, if the parts are made of iron, then those parts will be stronger than if the house is made of wood. Okay. Formal conditioning. This is a conditioning connection between the form of an entity and its properties. So for example, a fence made of sticks is strong as a result of the way the sticks are woven together. If they're woven together tightly, the form makes them strong. If they're woven together loosely, then the form will make it weak. Now let me give a historical example of how these particular concepts can help us make inferences. In the early 1800s, heat was thought to be a fluid which moved from body to body, causing its temperature to increase. And the reason they thought this is because they had identified a particular quantity, which they called heat, which caused a change in temperature and was always found to be conserved during a heat transfer from a hot object to a cold object. So since the heat gained by the cold object was always found to be equal to the heat lost by the hot object, many concluded that heat was a substance which was actually flowing from one to the other. Now, this hypothesis was completely consistent with all of the information known at the time, but there was insufficient evidence to prove it, and it turns out that it's wrong. The categories of formal and material conditioning, which I've laid out, could have helped scientists to realize that there was a second possibility in this situation. The heat as a fluid hypothesis is a kind of material conditioning. That heat is an entity which moves from body to body and it conditions temperature. But my concept of formal conditioning could have alerted these physicists to the possibility that heat is instead a property which moves from one body to another without the exchange of some entity. Instead of changing the matter of each entity, contact between hot and cold objects could have been changing the form of each entity, which, the relationships between the constituents. Now later, it was proven that heat involved formal conditioning. Since heat was found to be the relationship between the constituents, specifically the motion of the constituent atoms with respect to one another. So these two concepts of formal and material conditioning could have avoided a hasty conclusion and alerted scientists to the full set of possibilities which were worth investigating in their context of knowledge. And next is efficient conditioning. Efficient conditioning is a conditioning connection between the properties of a first entity and the properties of a second entity it is in a relationship with. Example, during the instant that a bat hits a ball, the force on the ball will condition the ball's acceleration. Now, for reasons I will explain later, I conceptualize force as a relationship between two entities, not as an action. So I'll talk more about that later, but force here is efficient conditioning. It's a relationship. And that leads us to a new category. This doesn't have an equivalent for Aristotle, although Aristotle talks about this a little bit. That's passive conditioning, which is a conditioning connection between the properties of a first entity and the way the properties of a second entity condition the first entity's properties when in a relationship. Okay, this is a little much, so think about the example. During the instant a bat hits a ball, the mass of the ball will condition the resulting acceleration. The larger the ball's mass, the less acceleration the force will produce in the ball. So you will notice that in F equals ma, F is the efficient condition and M is the passive condition. Now, in lecture 4 of the inductive summary of physics, Newton found that different objects accelerate differently under different forces, under a certain force. Now, using the concept of passive conditioning, he could have used the observation that different objects accelerate differently when under the same force to infer that some property of each of these entities, some kind of passive condition, makes the same force affect them in different ways. He later proves that this passive condition is mass. Now, one purpose of these 4 concepts is to identify the different known ways that an entity's properties can condition its other properties. This serves to direct our attention during a scientific investigation. When trying to understand an entity's identity, we can ask 4 questions. We can ask, what is the entity made of, and how does that determine its nature? That's material conditioning. We can also ask, how do the parts relate to one another, and how does that determine its nature? That's formal conditioning. We can also ask, what other entities are in a relationship with this entity, and how does that determine its nature? That's efficient conditioning. And finally, we can ask, what is it about this entity which will influence how it is conditioned by other entities? And that's passive conditioning. Let us now turn to two concepts of mind which are based on Aristotle's matter-form distinction. First, material entity. An entity having particular properties which are the result of material conditioning. Next, formal entity. An entity having particular properties which are the result of formal conditioning. Let me demonstrate these with a common story. There's this ancient Greek riddle called the Ship of Theseus. Theseus was a Greek hero who sailed around the Mediterranean for several decades. And as he sailed, different parts of his ship wore out and got replaced. Now the riddle is this. If after many years, every plank, rope, and sail has been replaced, then is it still the same ship? Now further, to make this even more funny, let's say that you somehow collected all the old parts that got replaced and you made some kind of like really decrepit Ship of Theseus out of it. Is that the actual Ship of Theseus? Now, the answer to this riddle depends on if we are referring to the ship as a material entity or as a formal entity. If the original ship was made out of some kind of special wood and we wanted to get a piece of that special kind of wood, then we are concerned with the ship as a material entity. The entity whose properties are the result of it being made out of a particular material. If instead we are interested in the properties which result from the particular relationships between the parts, so for example, a certain cargo space, a certain crew capacity, or of course, the property of being the actual Ship of Theseus that carried Theseus around on his voyages, then we are concerned with the ship qua formal entity. We aren't concerned with the material, but we are concerned with a persisting arrangement of changing materials, which creates an entity with those particular properties of Theseus's ship. Now, both perspectives, that of material entities and of formal entities, is crucial. Remember that what we take to be an entity can change depending on our perspective, and it's critical that we be able to look at things from both of these perspectives. The material entity perspective is critical because some properties are the result of matter. If you burn a log and the ash remains, then the ash, is the same material entity as the log was. And you know this because the ash occupies the same position that the wood used to. Now, this helps us in chemistry because it's important to think of material entities in chemistry. In Lecture 7 of the Inductive Summary of Physics, Lavoisier urged his fellow chemists to take careful measure of the exact weights of chemicals that they put into their chemical reactions, and to also measure the weights of materials that they got out of their reactions. If no weight was added or lost during a reaction, then chemists could have used the concept of formal entity and material entity to know that they were dealing with the same material entities, and that any changes to the properties of their substances would be caused by changes in form. Now, at the same time, so that's why treating things as material entities is important, but at the same time, treating things as entities based on their form while disregarding matter is also a crucial perspective. The human body is an entity, even though it is constantly swapping out materials. Hair falls out, skin regrows, stuff like that. Now, I've actually heard that every atom in the human body ends up getting replaced over the course of about 5 years. But nonetheless, the body is still an entity because the relationships between its constituents remain the same despite the loss and replacement of materials. Now, let me draw your attention to an important example of a formal entity, and this is a wave. When one whips a rope, it produces a hump in the rope which travels forward. Something which is deceiving about this is that no one particular piece of rope is actually moving forward. Each piece of rope is only actually moving up and down. It's the hump which moves forward. Now, this hump can properly be seen as an entity if we take the right perspective. It has particular properties. It has a shape and position. And it commits particular actions. It will cause a force on the hand holding the other side of the rope once it gets there. These properties are a result of the particular set of relationships between the parts. And these relationships are maintained even though parts are constantly being changed out as the hump moves forward across the rope. The bits of rope in front of the hump are being introduced into the entity, while the bits of rope at the back of the hump are being shown out of the entity. So we can see here that my radical reformulation of the concept entity that I showed you at the top, that an entity is an existent with its own properties, this allows us for the concept of a formal entity, which in turn gives us an objective basis for calling the human body or a wave an entity. Now that basis is that properties of such entities persist even when their matter changes. And I think this will one day help us make inferences about quantum phenomena. And the reason for that is that in quantum phenomena, a lot of physical entities, such as electrons, are actually found to have the characteristics of a wave. So we want this kind of ability to be flexible about what we call an entity while still being objective about what we are calling an entity. So now that we've established, so at this point, we've actually established the concepts necessary for my unique concept of action. Here it is. Action, the formation or dissolution of a relationship. So let me demonstrate this unorthodox definition with an example. So let's think of a simple example, a bat striking a ball. As the bat comes into contact with the ball, a force relationship is created where none existed before. As I've mentioned before, I conceptualize a force as a relationship because it is one way that an entity conditions a property of another entity. When an entity is in a force relationship with another entity, it conditions the property of net force. Okay? The property of net force then causes an acceleration. So force is therefore a relationship, but a force coming into being is an action. When a bat strikes a ball, it is not the force which is the action, but the change in force which is the action. Now, this novel formulation of what an action is and what a relationship is allows us to capture a key distinction. Action involves one entity changing another, but entities can also influence each other's identities in static, non-changing ways. An example of this is water. In a water molecule, oxygen conditions the properties of hydrogen and vice versa. When the two atoms are bonded together, or when the three atoms are bonded together, it's not as though first the bond between the hydrogen and oxygen exists, then later it comes the capacity to quench thirst. No. The capacity to quench thirst, a property of the water, exists so long as the bonds exist, so long as the relationship exists. In contrast, if we were to synthesize water, then first the formation of the bonds would happen, then the drinkability would result. The bond is a relationship. The formation of such a bond is an action. My concept of relationship captures the way entities condition one another's properties in unchanging ways. My concept of action, on the other hand, captures the way that entities change one another's properties. And such changes are always brought about by the formation or dissolution of relationships. Now, here's a principle that helps us in inference that comes from this definition. Actions are always actions of entities. This basic principle allows us to infer the existence of hidden entities when only the actions of those hidden entities avail themselves to us. So let's say an ancient Greek sees trees getting blown by the wind. If he did, he shouldn't ascribe that motion to some kind of disembodied force, but rather to a force caused by some unseen entity. Later, if he fans his face, he might realize that he's pushing an invisible substance into his face with his hand, causing an effect which is identical to wind. If he were on the lookout for the entity which causes the blowing earlier, he would now be able to connect that rustling with trees with this stuff that he's now pushing into his face, discovering the invisible entity of air. Now, these kinds of principles can also be used to advance our scientific knowledge at our current state. Let's consider a similar case. In an electromagnetic wave, the shaking of an electric charge causes changes in the nearby electromagnetic field. These changes then cause changes in the field next to that location, which in turn causes a change in the field next to that location, etc., etc. This chain reaction, which was discovered by Maxwell, is found to be the underlying nature of light. Now let's look at this situation and analyze it with broad physical categories. Between every two locations, we have an action. Specifically, the electromagnetic field of each location changes as a result of the electromagnetic field of the locations next to it. Since a property is changing as a result of another property, we can see that there is an action going on. Actions are always actions of some entity. As a result, we know that there is some entity at each location, which is causing waves by acting on similar entities at neighboring locations. These entities, whatever they are, must be everywhere, since as far as we can tell, light can travel anywhere, even in the vacuum of space. Broad physical categories have thus allowed us to prove the existence of a hidden substance which is present even in vacuum. This substance has historically been called the ether. Now, a lack of broad physical categories is part of the reason physicists have made the mistake of rejecting the existence of the ether. Physicists now explicitly believe that the electromagnetic waves exist without being the action of some underlying entity. This has prevented physicists from making deeper inferences into the underlying nature of light for over a century. The application of broad physical categories to making inferences about the nature of the ether will be one of the primary goals of the inductive physics project. Now, we've understood action, and now we are ready for causal connections. Causal connection, a conditioning connection involving action. So remember, the general term for labeling a connection of facts is a conditioning connection. But only when such a connection involves action should we use the word cause. For example, when a bat strikes a ball, one of the factors which affects the way the ball will move is the elasticity of the bat. Different materials have different elasticities. And elasticity is the ability for a body to regain its previous shape after being deformed. You can see this really cool photo. In general, balls will bounce off of more elastic bats faster. It's more complicated than that, but I'll just say that as a general statement. We can therefore say that the bat's elasticity causally conditions the movement of the ball. Now, Similar to the difference between relationships and actions, a difference between conditioning connections and causal connections is that causal connections involve temporal succession between the connected characteristics, while conditioning connections don't. They're simultaneous. In the case of a bat, the bat's elasticity exists first, and then the motion of the ball comes later, being conditioned by the elasticity of the bat. In other words, cause comes before effect. Now, this fact about causal relationships can actually help us make inferences. Let me demonstrate. One can take the following perspective. You can say that rubbing a glass rod causes it to attract paper. And when you're doing this, you're talking about an action causing another action. Now, this is fine, but when you say that an action causes another action, you have to understand that you're leaving out causal middlemen. Entities do not just act based on previous actions. They act in accordance with their properties. This is a key point Ayn Rand makes, by the way. Those properties can be conditioned by previous actions, but the properties of the acting entity are always the more immediate cause. Okay? So when we say that the rubbing caused the attraction, we got to remember that it did so first by changing the properties of the rod. Then the rod, now having different properties, acted differently than it would have before. If we simply say that the rubbing caused the attraction, then we miss out on two key facts which will assist further inference. First, that the rubbing caused some kind of property in the rod. And second, that the new property caused the attraction. So temporal succession between causal factors often allows us to infer the existence of unseen causal middlemen. Now, on the other hand, if there is no temporal succession between the connected actions, then the actions don't influence one another through the process of an action changing a property, which in turn gives rise to another action. So for example, if we think about Newton's third law, it states that every force necessitates an equal force in the opposite direction. Now, these two forces are simultaneous. Therefore, we can make an inference. We know that they're not connected by some process of an action changing a property, which then gives rise to another action. We should therefore say that every force necessitates an equal force in the opposite direction. We shouldn't say every force causes an equal force in the opposite direction. Now, even though the creation of these forces are actions, there's no evidence that one of the forces conditions the other through some kind of fact of action. Okay, now let's use this same principle to make a new discovery. In lecture 14 of the inductive summary of physics, physicists find that the movement of magnets can cause swirling electric currents. Later, this is understood in the following principle. A changing magnetic field causes a swirling electric field. However, it is worth noting that there is no known temporal succession between the change in the magnetic field and the swirling electric field. It's true that moving a wire or changing a magnetic current causes a change in the magnetic field, since the movement of the magnet or the change in the current comes first and the change in the magnetic field comes later. But there is no known temporal succession between the change in the magnetic field and the swirling electric field. Since there is no temporal succession between these actions, they appear to be simultaneous. The change in the magnetic field might not be causing some change in the property of the ether, which in turn causes a further action of the ether in the form of a swirling electric field. The properties of a changing magnetic field and a swirling electric field might therefore just be two aspects of the same underlying property of the ether. So just as reasoning with broad physical categories could have helped Kepler see a relationship between the sun and planets, applying BPCs to our modern knowledge can help us infer the hidden nature of the ether. Now, just as I talked about 4 conditioning connections, there are 4 species of causes which also warrant our special attention. And of course, these will be similar to Aristotle's 4 causes, if you've heard of those, but I've changed them to fit my framework. First is material cause. Material cause is a material conditioning connection between an entity's matter and its actions. In other words, the kind of stuff something is made of affects the way it acts. If a steel sword clashes with an iron sword, it has a chance of breaking the iron sword. Formal cause. A formal conditioning connection between an entity's form and its actions. In other words, the relationship between an entity's constituents condition how the entity will act. So for example, in the case of isomers, we see that different arrangements of atoms led to different actions, namely, different ways that these compounds chemically interact with other chemicals. One purpose of these 2 categories is they help direct the scientist's attention towards important questions. If we were to ask, for example, what is the formal cause of chemical reactions? Then the case of isomers would actually show us that the spatial arrangement of atoms in a molecule play a key role in why certain chemicals will or won't react with others. Now, why is that? I don't know, but thanks to the concept of formal cause, finding out is now on my to-do list. So it guided my attention towards a question worthy of answering. Scientists can also ask, what is the material cause of chemical reactions? It is, of course, the different kinds of atoms involved in a reaction. Now, this can allow us to go further and ask, okay, well, if different atoms cause different reactions, then what is it about those atoms which causes different reactions? So these questions often arise naturally, but with explicitly formulated broad physical categories, we can now raise these questions systematically. We can remember to raise all of them, to cover them all, to mine them all for additional data. Now, the next one we're going to cover is efficient cause. And this is a conditioning connection between the actions of a first entity and the properties of a second entity. So for this one, I'm going to steal the classic example from Aristotle. A block of marble has the shape it has, let's say a statue, because of the actions taken by the sculptor. I'm stealing this example from Aristotle to indicate that this concept is unchanged. It's the same as Aristotle's, as far as I can tell. And then that leads me to something that wasn't Aristotle's, which is passive cause. And this is a conditioning connection between the properties of a first entity and the ways its other properties will change when it is subject to the actions of a second entity. So, for example, if a man is in good health, he might survive poisons which would kill other men. His health, a property, therefore conditioned how the poisoned changed his other properties, and this being the property of him being alive or dead. Here's some examples from physics of passive causes. Elasticity, a property which causally conditions the amount a body will deform when subject to a force. Another example is electric charge. You can actually think of charge as a passive cause because it is a property which causally conditions the amount of force a body will receive when it is subject to an electric field. Now, these concepts are helpful because the actions which create an entity often reveal aspects of its identity. When we ask, what is the efficient cause of chemical compounds? What kinds of actions cause them to form? Then we might notice that some reactions are endothermic. This means that they consume heat from their environment when taking place. Since heat is the motion of particles, which are involved in the reaction. And since chemical reactions are the breaking of some atomic bonds and the formation of other bonds, this allows us to infer that atomic bonds actually contain energy. Since the energy of motion is fused up into the formation of such compounds, we say that the bonds contain energy. Now, I don't exactly know what it means for atomic bonds to create energy, but thanks to the concept of efficient cause, I intend to find out. So, that concludes our categories for now. In conclusion, I have achieved the major two motivations for this investigation. First, I have shown how each of these concepts I've laid out can be used in scientific inference to help us probe deeper into the underlying nature of things. And second, I've used the method of cross-conceptualization to arrive at new definitions for these terms, and I have shown how my definitions capture distinctions and similarities that standard conceptualizations do not. I will probably modify these categories further over time, but the reconceptualizations I have made so far constitute significant improvements. Now, before I go, I wanted to make one last citation, and this is the most important citation. This presentation was inspired by a lecture by Mike Mazza of the Ayn Rand Institute. That lecture was titled Ayn Rand's Unique View of Causality, and it was given in 2021 at the Objectivist Summer Conference in Austin, Texas. So, if you have suggestions for how these categories can be improved, please leave them in the comments. I especially encourage you to read over my document of definitions a few times and check for yourself if you think I conceptualize them properly, and if you think they're in the right order, if you understand the issue of hierarchical order. Using these categories, I will next identify principles which will assist us in making inferences. This will be part of my forthcoming theory of induction, which I will use to reprove the essentials of known physics. This will allow me to rehabilitate the flawed theories of relativity and quantum mechanics, which will give us a new path forward for discovering new principles of physics. Thank you for your attention, and I hope you'll continue to join me on this journey.